Hello, everyone, and welcome to Functional Futures. In Haskell world, there are many particle physicists turned computer scientists, but today's guest is a computer scientist who helped particle physicists make sense of all the data they have gathered. Getting his education from legendary Fair University in Croatia, he currently resides in Austria, where he is making Erlang-inspired Wasm runtime called Lunatic. Bernard, dobar dan.
Dobar dan. Thank you for having me.
Yeah, I learned about Lunatic a while ago because my friend and one of early circulars, Ante Kegel, was contributing to your stuff. So yeah, it's a small world. Can you please tell our viewers about kind of what Lunatic is, how it evolved from like an idea, and what's the story behind this name?
Sure. So Lunatic is basically a WebAssembly runtime inspired by Erlang's principles. It's an attempt to bring some of the ideas from the Erlang world to all programming languages that can compile to WebAssembly. When I say ideas, I mean we bringing the concurrency model based on processes that don't share any state with each other, the message sending between processes, linking, building abstractions such as supervision trees, and also like the distributed part of Erlang. So I can spawn a process of a different node and just have it magically run and send messages to it. So like the interesting part is actually the WebAssembly component of it. So I can give an example of how Rust works currently, or library. I think this will paint a picture like how the fundamentals underneath work. So basically, if I first attempted to do something similar to Erlang in Rust, and if you want to do it, like you kind of need to use async Rust and tasks in async Rust. But you have always this issue that Rust applications have one memory space, right? So if you have like a task, you spawn it, it's running, and if it messes something up in this memory space, corrupts some data, even if you restart it, you don't get like a fresh memory like in Erlang process. So this like fault tolerance part is always missing and hard really to get. And also there are other issues with async Rust. For example, if you're having some intense computational part in Rust, and you run it and you don't yield back to the executor, basically it's gonna get the thread stuck and the responsiveness of the system will suffer. So like there are like different also ergonomic issues because you cannot have async traits in Rust. So there was like a bunch of different issues. And in Erlang, it kind of feels so elegant. You write your code in a linear way, no coloring of functions, no like async await, and it still works in a high performant I would say like a scheduled way with virtual text. So like my idea is like how I'm gonna have this experience in Rust. And at the same time, I kind of also discovered WebAssembly, and these WebAssembly instances are really similar to Erlang processes. So basically, each WebAssembly instance gets their own linear memory. So it's like similar to Erlang process heap memory, and they have their own stack. And so what we do with Lunatic, we kind of insert also preemptive points in the bytecode. So we take a Rust application, compile it to WebAssembly. So we insert preemptive, basically a reduction counter, like if you're familiar with Erlang. So it after the application runs for some time, it will yield back. So you kind of can write any code. You can even cross compile, take some C code base and link it together with your Rust code base, and everything stays always performant, yields back at the same time, and works fine. So we basically, through WebAssembly, we introduce kind of a new concurrency model to Rust. You can not only spawn like async tasks, but now you can spawn like WebAssembly instances that are small computational isolated modules that have a mailbox, so you can send messages to them, and you can also link them. So basically, we try to bring some of the Erlang ideas to particularly now Rust, but we are also focused on bringing it to different languages that just compile to WebAssembly, because our main abstraction is kind of this WebAssembly instance. And yeah, like regarding to the name, that's a point I wanted to come. In the beginning, I actually did not know about WebAssembly, and when I wanted to have more kind of high performant Erlang, I started working on a mix between Lua, because I knew Lua had like a really amazing JIT compiler. So I was doing a Lua runtime with some elements of Erlang, and I named it Lunatic. Like, and also logo, if you notice, it's a moon, like also inspired by Lua. So that's where actually the name comes from. And I just kept the name, but the project is now in a completely different direction, and it does not really have any more like parts of Lua inside of it.
Yeah, the swan flew away, but the name stayed,
Yeah.
as the classic wrote. That's really cool. Well, you're saying a lot of stuff about WebAssembly, and you're saying how it's basically the core idea of your project. But I will be honest, I'm not a huge expert on WebAssembly, and to me, understand the basic concept, right? Of the and when we basically compile some stuff and then we inject reduction counting
Mhm.
into it, um, which I can kind of see how it could be done, like in like an arbitrary virtual
Mhm.
machine, by. And again, this is something that I'm interested in, right? How do you even do that, right? Because like, is it static analysis? Is it just scattering some instructions all over the place and hoping for the best? But yeah, for me, I would like to kind of f- learn more about like what actually is WebAssembly, and why WebAssembly, why not JVM, for example.
Mhm. I can give a short intro just like to WebAssembly for people that are not familiar with it. Basically, I think the web name inside of the WebAssembly is a bit unfortunate because, I mean, nowadays WebAssembly is mostly deployed inside of the browser, so it makes sense. But WebAssembly is just basically a bytecode definition. It's a really simple bytecode definition that maps good to modern CPU instruction. So you kind of can compile it really fast to like some really efficient code that the computers can execute. And the opposite of the JVM, it does not have anything else. Like it doesn't have a garbage collector. It does not have any APIs. It's like completely like blank. And that's why it's such a good target for languages such as C, C++, Rust, because you kind of WebAssembly does not assume any runtime. It's always meant to be embedded somewhere else. So you compile some code to WebAssembly, and then you run it, for example, in the browser, and then you can expose to the WebAssembly code some APIs through JavaScript, so you can talk with JavaScript. But this interface is always like just like integers, floats. There are no string types. It's always super low level. So like WebAssembly gives you a way to just abstract away from the hardware a bit. So we use this also in part of distributed Lunatic. So you can spawn different nodes running different operating systems and different CPU architectures. So basically, you can say like spawn, like run this Rust function just on this other machine, and we transfer in the background the module, just compile it to the native architecture, and then run it there. Once you have this kind of bytecode abstractions, you can do a lot of interesting stuff. Because once you're limited to machine code, you cannot. It's not portable. First of all, the code, but once you are what for we use WebAssembly is also to insert instruction for reduction count. Basically, what we do is like we take care if you're running a loop, for example, we make sure like that you cannot get into the loop, but without running at least like one reduction count instructions. So you cannot have an infinite loop that will just occupy a thread and occupy all the resources and never yield back. So you can try to insert it at interesting points and never go like too many instructions in a row without yeah, it's not static analysis on the Rust, let's say, code or C code. We can take any bytecode, basically WebAssembly bytecode, and then we analyze it and then put the instructions there. And it's like a step, basically, during the just-in-time compilation. This happens. We use a compiler called CranLift, like that allows you to like basically generate efficient machine code from WebAssembly. So like while this process is going on, we just like put like extra points like now yield back to the scheduler. So the whole system stays responsive and we get this low latency part like that also Erlang promises. And I think it's really interesting because Erlang gives you low latency, but if you want high performance, you kind of need to drop down to C and then you have NIFs or like you have also Rustler is a popular project, so you can kind of link Rust native modules. But once you do this, you kind of lose all this responsiveness of the Erlang virtual machine, and then you're again on your own. You kind of need like to write some code that yields periodically back. And if you just pick a library like for image processing, you cannot really modify it like to not do too much image processing and yield back. And I think this like having a in between bytecode that we can monitor, and we don't really care about it because you can cross link like multiple projects and do C half code base, half Rust, and it will just work. Like we don't really care. And what's also important for WebAssembly, as I mentioned, it does not have any APIs. Basically, we call them host functions. It's the layer between the code running inside of the WebAssembly module and the host environment. For example, a good example of a host environment is the browser. So you can expose some functions and to interact between the browser and the WebAssembly module. And what we do it with Lunatic, we expose functions so you can spawn new processes, send messages, and because it also does not make sense for many constructs that live in a programming language. For example, in Rust, threads. Like, what would it even mean spawning a thread in a browser? Because most of the execution is single-threaded. So this functionality is just not available when you compile down to WebAssembly. So this kind of also helps us eliminate all this error that we would have if somebody is running a process and just suddenly starts spawning threads, because this is just not allowed by design. So if you go to WebAssembly, so WebAssembly gives us a bunch of these limitations that we use to create like this nice environment, and we set the rules, kind of what you can do and what you cannot do, and we provide a concurrency model so you can kind of get really close to this Erlang feeling of applications. Like I hope it was a bit like not too many things at once, but I
Well,
can clarify.
gladly we'll get to some of the stuff that you talked about a little bit later in the podcast. I just wanted to say two things. That first of all, it's a great thing that I actually forgot about when you were presenting Lunatic in the first place. That you get reduction counting for C for free.
Mm,
It's like amazing. I want to do Erlang a little bit of justice here, though. As far as I remember, in 2014 they have introduced a kind of separate scheduler
mm,
for NIFs, which is time based instead of being reduction based. I'm not sure how well it worked out. Based on what you're saying, is like not too well,
mm,
but at least to my knowledge, there was work done and like responsiveness, at least of hanging NIFs. Like we
mm,
never have at least like completely hanging NIFs that ruin everything. And NIF is native implemented function for our viewers who are not familiar with Erlang, which is basically a way to FFI your C code from Erlang. Um, all right, so I have the immediate follow up here to that, like a follow up question. Basically, you said that you're using a compiler called CraneLift, right?
mm,
And so again, I'm sorry for perhaps not enough podcast preparation. So, but yeah, so maybe my question will sound a little bit silly to you, but so am I right to understand that you're kind of patching this compiler to get Lunatic working?
No,
Or
I mean it's just a way to generate machine code from WebAssembly bytecode, right? Like the compiler does this. By I think it's also used by Firefox, at least the mobile version, if I remember correctly. So it's like also developed. I think majority of developers that work on the compiler are working for Fastly, and they have done like an amazing job, and they have actually invested a lot of time in figuring out like this reduction counting steps, and they also have like a different approach to it in the recent release. Basically it's also not reduction counting, but it's like time interrupts. Every few uh, like milliseconds you can get like a time basically signal that you should yield back so you don't spend too much. So they have like multiple approaches, and like basically all the effort lies with them. In the first iteration of Lunatic, this didn't exist, so we like needed to do a lot effort on our own. But this kind of became a popular way of handling stuff in the WebAssembly world and using these virtual stacks like and switching between instances. So like this is like now kind of part of the tool chain we use, and we don't need to worry too much about it on our own.
No, it's really nice. It feels always great to get validated by industry immediately. Even
Mhm.
yeah, it's a rare feeling, but somewhat familiar one. Uh, okay, so let's just wrap up the compilation part. So you're saying that basically there is some sort of like universal Wasm runtime, or
Mhm.
and then when you say that we're compiling to machine instructions, I assume that we get like binaries that we can run on, let's say, Linux or something.
No, like this happens. Like we compile it, we take the WebAssembly and then
Hmm.
compile the machine instruction into the memory and then execute it right away. Because WebAssembly was built in such a way to run in the browser, first of all. So the startup speed of it is really important. So it's like such a simple bytecode that you can kind of just like run through it and generate machine instructions. So it does not take much. You don't need to pre-compile it, save it on disk, and run it as a binary. So you can do everything kind of dynamically. So also when you open a web page, it just like downloads the WebAssembly, it just runs it, and we do something similar. So there is not this. And there, I mean, WebAssembly is kind of, as I mentioned, meant to run in an embedded environment. So browser, like it's one of them, Lunatic, like another one, and but it also runs kind of as a plugin system in terminals. Like somebody built a terminal application and uses WebAssembly to extend the terminal capabilities. It also runs in databases nowadays to bring compute closer to the data. So it runs in so many places, and people use it in slightly different ways because it does not have any assumptions around it, like just it's like bytecode. So you can kind of provide host functions that extend it. There are a few standards. For example, WASI, it's WebAssembly system interfaces. It's just like a POSIX-ish way of writing to the standard output, standard input. So, or the compilers, like the Rust compiler, if you compile something and print hello world, it kind of defaults to this like standard interface. And it allows you also to open files, but it still doesn't have capabilities for opening networking connections. For example, in Lunatic, we provide our own system interface, like to do so. Like if you want to open a networking connection and send just like load or contact somebody outside of the host. So it's still not a standard official, but we kind of try to provide this features that people are always gonna need, like until it becomes a standard, and then eventually you're just gonna be able to use the Rust standard library, and we will be able to generate WebAssembly code that's just works like so. So, but until then, yeah, you kind of need to import our library to do this stuff.
Right. I think I have a clear, much more clear understanding of what's going on there, and I guess for real, the final question about the sort of runtimes is um, when so okay, so Lunatic, you said, has host functions for files.
Hmm.
Oh, sorry. So something else gives us. So Wazi gives us
Yeah.
file IO. Lunatic has gives us network IO. What will happen if I? So first of all, can I? So from from the code that
Hmm.
I am intend to spawn as a Wasm instance, can I refer to from like the function itself? Can I refer to these capabilities?
Yes, you can. You kind of can. We provide like one interesting aspect also of WebAssembly, like that I did not mention. Each WebAssembly instance has a really strong security context, also because of the origin that comes from the browser. So we can do much more than you could do with Erlang processes. You can, for example, spawn just a function, like a process from a function in Rust, and then say this like function does not have access to the networking part, or like this function can only open this specific files or has access to this environment variables, and we can do this on a per like process basis. And this is like really useful if you have architecture like in Erlang where you have a web server and each request is kind of a separate process. You can just completely sandbox it, and it opens you all this like possibility around like supply chain security. Like if you use another library that you don't really trust, you just spawn it up in a process, give it a memory limit, no access to anything, and then you kind of have it like completely sandbox, and you don't even care like what C code is inside or anything. So like this is, I think, a interesting concept. So while you're running inside, you can kind of query like the runtime, like can I write to the file system, or like can I open this file? It works in that way. So it's like capability based, as you mentioned. So it's like a really interesting concept.
Nice, and I assume that, for example, when I'm trying to use, let's say, okay, let's say I want to run rebar in it's which is like an Erlang package manager. Let's say I
Hmm.
want to run rebar in browser for some reason, maybe
Hmm.
to analyze some Erlang project. Rebar writes rebar log. I think it
Hmm.
writes log file on disk. Let's say I somehow manage to compile rebar to Wasm. What will then happen if I try to spawn rebar in browser, and
Hmm.
it will try to, without, because obviously rebar won't check if it has capability to like write on disk. It will just try to write.
Yeah.
Like what will then happen?
First of all, before the WebAssembly module is instantiated, created, you need to fulfill a contract between all the host function being available. So, or it will just not work. It will say like open file function not available, so it will not instantiate it. And you need to provide something in the browser. What people usually do, there is a JavaScript implementation of a virtual file system, so you kind of can fake files inside of the browser or save it into the local database. I don't know, like all the browser APIs that you have available. But basically, you are free to define whatever you want, and you actually don't need to do the things. So you can kind of write to the file, and your WebAssembly module or rebar is going to think it's writing to a log file, but you can kind of proxy it and send it over like with the networking, because you just need to fulfill the contract interface. But how the implementation actually works doesn't matter. And that's also something like what we take advantage of in Lunatic. Like we provide some host function, but like in some concepts, like we want to do something else. Like you're like writing to a file, but we kind of just want to proxy it and give you a virtual file or just in memory file. But your application is not even aware that this is happening. So it opens like all this possibility, because you're in an embedded context. We can control everything, and you think like I'm opening files, opening networking connections, but we are just doing something else in the background. Like this bytecode abstraction gives you a lot of power.
That's really nice. I was actually a big chunk of my question prep was dedicated to distributed Erlang. So let's and distributed Lunatic. So let's move there. I think it's a nice and smooth path that we took, because when we talk about distributed Erlang, many people say that, oh, it's like not stable, or people shouldn't be using it in production. Well, I will be honest, I use distributed Erlang in production all the time, and I know that it might sound a little bit insane, but I have very battle proven architecture where basically you run your machines in the cluster as a federation, rather than like trying to share consistent state between all of them. And
Mm.
these federated machines trust each other, and if one goes down, then you basically have and you also have a way to distribute the load, and as long as you're writing application in a federation friendly way, you're good to go. But what really annoys me about distributed Erlang is the fact that it was made in the 80s, and zero trust architecture wasn't the thing back then. So our clusters, for example, when we do clusters that aren't like within one data center and are really physically close together, it kind of starts to be maybe not even problematic, but just scary. It's like it becomes harder to sleep at night, when you have distributed Erlang stuff running in production. Perhaps even developers have access to one machine, and then by proxy they have access to all machines, and they can just run arbitrary code, and malware on their computers can run arbitrary code, and then it's crazy. So yeah, as far as I understand, with Lunatic, when it becomes mainstream, we will not have to worry about it anymore. If so, then can you please, talk a little bit about distributed Lunatic and idea, state of the initiative, etc.
Yeah, it's like still, I would say, in early stages. We are like working on it. My co-founder Hervoy, like he is now investing a lot of time into it, And the approach we are basically taking, we want to make it at least not based on a 90s architecture. So we want to use modern like technologies like encrypted by default. We're planning to use quick, like the underlying protocol, like it's UDP based and allows you a lot of advantages. I think Erlang is using TCP, and there are like all these kind of issues, like don't send that too
Absolutely, yeah.
big message, because like if you, while it's sending, you cannot do the health like heartbeat message, then your node just falls out of the cluster. I think like it's a bit really not the most stable. I think that's also one of the reasons why like Fly.io as a kind of hosting platform is so popular for Phoenix and Elixir applications, because they offer you this virtual network VPN, like based on WireGuard. So like, kind of you're on a layer above, like, and everything is still encrypted while all these nodes work together. So yeah, we want definitely this to be by default, and the rest is really, I would say, similar to Erlang. So we don't want to give too much of an opinion about like how you should structure your distributed application. We'll leave this to developers and libraries. So we want you to be able to uh, have multiple nodes connect and like basically say spawn me a process on this node or link to it, or like let me know when this node goes down, and like have this basic functionality that you can build upon, but everything to be like encrypted and no blocking, like messages blocking each other, so you can have multiple streams. Like that's what quick actually enables us to do, and it's a bit better performant than TCP in many scenarios. So yeah, like the main idea, like in the programming model, like it's really similar to Erlang, but the underlying technology is, I would say, like just more modern and should work better, hopefully. And I had a prototype kind of distributed um, implementation that I disabled in the latest release. It was the original version was using just TCP. I just wanted to see if it works, like the concepts behind it. If you can spawn a process, and especially if you are running on a different node that has a different CPU architecture, you kind of need to transparently move the WebAssembly like to the node, and then have it there, the native code, so you can kind of just like spawn some process there. And basically it worked fine, and then now we're like, okay, this like approach is great, now just we want to build the underlying fundamentals really stable and in a performant way.
I wonder how, like, kind of tying it back with the original set of questions, like how um, kind of first class would capability discovery be in situations like this? Like, for example, let's say I'm running a node in browser,
Mhm.
and perhaps there is some like cryptographically assured protocol that I should be able to, like, let's say, mutate state on some server.
Mhm.
Would I be able to? And yeah, so yeah, so would it be like reasonable to write an application like when distributed Lunatic is out? Would it be reasonable to like write an application that basically queries the cluster, like heterogeneous cluster, for capabilities, and then like just sends like a function, maybe a closure somewhere to be evaluated there, without even, like writing
Yeah,
JavaScript code or
I
something?
understand. I think I understand the idea behind it. It's like I also spent some time thinking about it, like how we could do this, especially for example, if you have let's say a database somewhere running, and you want just to send something to be executed close to the database on the same node. So in a way, like to query for it, like the fundamental protocol does not have this capability, but I was always imagining it working in some way that you have kind of process running on each node, and you have like store some information that what is available of hardware, for example, if you need specific hardware on this machine, or specific other processes living, and in a way you kind of query it, like say like, oh okay, like that, which of them has it. So it would be a kind of higher abstraction. This knowledge is not like directly inside of Lunatic and the nodes, but you kind of build upon it. And I imagine such architectures, everybody's going to have a specific use case. Like you're going to be querying for specific information. So like I leave it up to developers to develop systems around it. We don't also want to be too opinionated, like how you should like structure your application supervisors. So we want to give developers the freedom to organize the code in a way it fits the domain and the problem they are solving the best.
Well, uh, that's a very noble cause. I think that Ericsson also had this while designing Erlang. But what ended up happening with Erlang, as we know, is that there are two abstractions that are sufficient to claim that the one is an Erlang professional, it's a supervisor, and a Gen server. And you can write anything in Erlang using just this two. Obviously, it's to a degree it's a joke, but yeah, you mentioned that you don't want to like impose architecture and stuff like this onto the users. I wonder what will you do about OTP and like will you ship with it?
Sure. I think there are two parts like of the VM. First of all, there is like the fundamental just runtime that's implemented in Rust and compiles to native code and then runs the WebAssembly, right? And then there's this guest libraries basically that you use to write application that take the libraries, they expose capabilities of the underlying platform. So we provide in the platform the minimum amount of things like processes linking together, like processes, messaging, mailboxes, and this like that you cannot really do in the guest space. But everything else we provide. For example, we have supervisors in our Rust library, so you can and some abstraction that are similar to the Gen server. So you kind of can write Gen servers and the supervisors, but we provide it. It's also similar, I think, to Erlang, like because OTP is like kind of library, and so we provide this also as a library on top of it. And I think it real now we are focused a lot on Rust, but it really depends these abstractions on the language you are using, right? The one we are exposing in Rust take care of the we take advantage of the type system to make the expressing of how our supervisor works, what the children are, and the supervisor strategy. Like it depends a lot on the Rust type system. We wanted to make the programming model feel really close to the language. What we do, for example, in Rust, we stick to cargo and the default tools. So if you know Rust, you just basically change a cargo config saying the runner is now Lunatic. So basically all the WebAssembly modules that are running are prefixed by Lunatic. So basically Lunatic and then loads the WebAssembly. So if you do cargo run, it just like runs on Lunatic, compiles directly. If you do cargo test, everything works out of the box. So the developer experience feels native. And we also want the libraries to feel native to the Rust developers, because it's sometimes in the beginning it was really hard for us to take some of this Erlang concept that are pretty dynamic and the language is really dynamic and kind of shove it into the Rust type system. And some things did not feel natural and we needed multiple iteration until we got it right. But I think at this point we have a really good foundation for it, and we take advantage of the Rust type system. For example, we have session types in the that we introduced in the latest release, so you kind of can spawn processes that communicate and define the protocol in the type system up front. And what happens, for example, if you like drop this object that communicates earlier, it's like the process panics, and then also the linked process panics. So if one part hangs or something, the type system kind of assures that everything blows up, and then you don't just have hanging processes somewhere. So we kind of try to take like the best parts of Erlang, but also the best parts of Rust and the type system, and merge them together into something that's like really powerful.
But can I still write a Wasm, like compile a Wasm program that will send arbitrary garbage to
Yes, you can. You can
to
definitely, because what we do, we also expect people to sometimes write in different languages. So you write in C one process and another in Rust. So the messages that are sent between each other are just buffers, like because we cannot make any assumptions. So like you can serialize any data you want inside of it and deserialize on the other side. and we leave this up to the developers, the serialization format and stuff. It's just like, here's a buffer, like write something in it, and we will ship it like to the other process and let it know it arrived.
Yeah, that's really cool because it also, in my humble opinion, it also allows people to focus on the actual functionality of the system rather than being obsessed about how to model every single thing
Mm.
in types, how to model every single possible use case of a channel, etc. By the way, when you were talking about session types and stuff, I immediately remembered here in UK there are people company called Ideas with a 3 instead of E. And what they did, they are now basically are using pure script. Uh, so they have something called pure Erl, which is a pure script running on Beam. And they obviously, like, pure script is very tight as far as types are concerned. So they had to think a lot about actually making their own like OTP, because it just kind of, you can't just port OTP to pure script, like it's impossible, exactly because of the dynamic
Mm.
nature. And yeah, maybe if you have free time, you can look it up.
Yeah,
I think
definitely. Thank
they
you
did.
for the recommendation. I will look into it. I did not hear before about it, but I what I looked into was Gleam, like the language. I think you had also Louis like on the podcast before, and I was a big fan of Gleam in the past. So I like right away looked like how they are doing kind of the typed message sending. But like at this stage, like when I looked at it, it was like really early like stage, and it did not like I did not feel like it was a perfect fit. And they also, I agree with you like completely on this. You kind of always need to have this escape hatch. Like if somebody wants to do something, we don't want to enforce everything to type systems, because sometimes I also need like just like to send something between process. I just gotta pipe this in, like whatever it is, and take care of it, because I don't want also to lock in developers too much. I think always if you have this kind of escape route, let people accomplish if they need something in a dirty way. Let's say it like this. But I mean, sometimes you just need to ship stuff. You cannot reason forever about type systems.
Right, and gladly are it's just a message in the mailbox, right? If the actor doesn't want it, can just drop it.
Mm,
So yeah, by the way, in terms of Gleam, I also remembered about the Gleam, and I was poking at it a little bit, and what I found lacking, and this is it's a long story. I'll try to keep it short. So what I found lacking is the following. Well, is process register, like a way to register processes by name,
mm.
and it's impossible to to solve it in general in type system, because you kind of can't have a situation when you create some symbol or name, and it can point to either a live process or dead process, or it points today to one process and tomorrow to another process. Strict formalisms don't really like that sort of stuff. So yeah, I guess part one of the question is how do you handle this, and do you handle this?
Yeah, like there are so many like interesting kind of similarities when you once start doing Erlang in a typed world. Actually, I had a similar like trouble that how do you name processes? Like you register a process with a type, and we can encode a lot of information in a type. Like it's like the serializer format, the serialization, everything is kind of type hints that works just automatically. If you don't define anything, it just uses the kind of default serialization format, like it's Bing code that's like kind of really performant in Rust. And but if you encode some information, so like how do you look up a process, because the lookup is just a string. So what we do is we take the name, the string, and then attach like a plus, a extra part to the string that's a stringified version of the type, right? So if you're looking up, you kind of need to define the type, give a type hint basically to the compiler. This is compiling to this basically pointer to the process, and then the name you're looking up needs to match this type, right? If it does not match the type, it will just return the process doesn't exist in the system. So if you are looking the same name but the wrong like process type that expects like the wrong kinds of messages, it just returns it doesn't exist in the system. So you kind of still get a bit of safety, but you also can work around. We have an unsafe version, just like look up like process under this like direct name, and just make sure you send it the right kind of messages that the process expects. But yeah, like we can like stringify the type name inside of it, so if you don't give the right type hint to the compiler, it will not succeed in looking it up. But if it succeeds, this means like the messages you're sending to it are going to be correctly serialized, deserialized, and everything is going to like the correct message types are going to be sent to this process.
So yeah, I have like two additional questions. Well, first question is what happens if I got the process ID or whatever is the abstraction named in Lunatic from resolving it like this and send first message which crashed the thing, and then like I want to send another message to like a stale bit, for example, like what will happen?
So first of all, there are two kind of scenarios. If your process is attached to the supervisor, it will restart it, and like the new process will. You can hint to the supervisor, like name it the same way like as the previous one. So it has gonna have the same name. But right, the one that you looked up previously, like that you're holding, it's still pointing to the wrong one. So if you send something, like it's not, the message is just gonna be dropped. It's not gonna end up anywhere. So what you would need to do is like look up again and send it. So if you are like not sure, like when you're sending messages, if the process kind of crashed in between, I mean, you can always link to it so you kind of know if it crashes. But the correct way is kind of look it up every time before you send it, because if the process can crash, like you never know under what process ID it lives.
Nice. So it's like so your primitives already, or well, your functions already support all of these scenarios, right? Of
Mm,
the like dynamic lookups and stuff like this.
yeah.
Okay, that's really cool. And yeah, obviously. Oh yeah, by the way, like how big on let it crash is Lunatic? Like on the kind of on the spectrum of offensive programming, like how offensive is it?
It's like I think I mean I think it's somewhere halfway, like where Erlang is and like where like Rust is. I would say it's somewhere in between. So what I really think, like Rust developers often tend like to kind of handle all the error tree of messages and can be quite verbose, like unpacking everything. And what I do when I write Lunatic application, I often just unwrap. I'm like, okay, I expect this to be there. If it doesn't, I unwrap. If it crashes, the supervisor may restart it, and it maybe work depending also on your architecture, because you cannot do it with everything. But I also like to use sometimes the type system, just like I'm receiving a message and I want just to match all the, for example, all the error paths like that can happen. In some cases, it's really important to handle. It really depends, I would say, on the scenario. My advice, it's always like be practical. Like if you think like this is really not expected to crash, then just like crash. I mean, you don't need to recover, because it's also really hard to recover from all kinds of errors. But if you kind of can handle it simply like the error, and you expect it from time to time to fail, like then just handle it like it's no big deal.
Yeah, this is actually a whole rabbit hole of thinking about faults and errors, and if there's so yeah, like I have a colleague who says that who's very wise, and he says that we should never confuse faults, like system faults, with uh, programming uh, errors, like when we basically write a bug. And we should also always remember that sometimes failure is part of a happy path. So
Mm,
sometimes, so we have to kind of, as a programmers, we have to like have the distinction of these three concepts, right? Faults, which we shouldn't handle, programmer errors, which we should somehow find, right? It's like it's not. you can't, like, no amount of Erlang or no amount of
Mm.
type systems will help us uh, when we have a kind of discord between the problem domain and what we're writing in the code. And the third is that sometimes just things, like as you said, sometimes you just expect something to not work and it's normal. Yeah, like for example, opening the, like pressing on a washing machine handle, right, is a good example, right? You sometimes expect for it to not let you open the door, right? It's, and you should handle it in your robot AI or something like that. So yeah, so yeah, coming back to the questions about dynamic processes. So I actually was wrote like a very naive, one would say, spec for, well, improve, not even improvement proposal, just an idea for Gleam, uh, which happened to reinvent uh, Microsoft Orleans. I don't know if you have seen it,
I
and what's
just
your opinion?
yeah, somebody mentioned it on the Discord of Lunatic. Like, so I had a look at it, but I never tried. I mean, I just like heard of it, like looked it up, what it kind of was, but I'm not familiar like how it works or the details about it.
Right, right. Well, my idea was to be able to kind of uh, write out types. Let's say I say that I have a, like an animal type, and then sound type, and the idea is to have kind of like a type constructor which would take animal and sound and create a protocol that allows uh, to send like sounds to animals and have them like react to the sounds somehow, right? So this is like and then when you write, then when you use this constructor, your compiler will generate the code that would create like an instance of each animal, let's say, that allows like, and then I can just say like send the uh, meow to mouse, and the mouse will run away, let's say, and it will kind of just be there instead of programmer having to create an OTP tree, let's say. We just, yeah, we just make sure that, like, by with code generation, we generate the stuff, and then we type check, obviously, that, let's say, we don't send, I don't know, uh, washing machines to animals, because it wouldn't make sense, I think.
Hopefully. uh, yeah, I mean, there are these like different approaches, like how to do it, and it's, for me it's always kind of hard to find where to put the line, like what I want basically the developer to express, and what I want the system to automatically generate and how it would behave. So it kind of can go like into extremes on both sides. Like we kind of are pushing more with Lunatic towards the developer decides a lot of it, but I can see a lot of appeal in this other side, where you, for example, have this higher level like constructions that you kind of just work with, and they exist there. So you define some stuff inside of your code, but other things are just kind of automatically mapped or exist. Like it's a bit like this, like kind of services that are discovered. So like you're kind of writing an application and you're like saying like, I just need like a service for handling this thing, and it's like you're automatically mapped to this service, and like now it works. So you kind of write part of the code, but the like rest of the contract is fulfilled. Like I could see like this being built like on top of Lunatic, but there's like, it always feels so domain specific, right? Like every time you're solving a specific problem, it's kind of hard to make it general. At least like I did not know how to do it. I kept thinking about it, but like every time it's like solving a specific problem for a specific kind of domain, but it's hard to make it in a general way that everything works. Like if you give the example like with rabbits and sounds, right? But like once you move like into more different domains, like you have like I don't know, a football team, and like they're passing the ball between each other. Like, what does this even mean? Like, what's like how is this like it's like completely different kind of mapping of reasoning about the things. So maybe you also need kind of to change your system around it. So yeah, it's like, I mean, it's still like a bit of a struggle, right? Because we want to be as good to developers, like give them as much power as we can, but also not like to limit them what they can do. Like, it's always like these examples like of this super nice frameworks, like you can do everything and everything's just one click, but as soon as you need to do something that's a bit unusual, then it's like completely disaster, because you kind of need to rewrite around the rules, and it gets a bit hard to do. So yeah, like I hope like we can, because also Lunatic is like a bit early project, we will be able to find a balance. And I also looking forward like for suggestions from people, like from the community, like to just tell us what they would like to see and like how they think it should work. Like, it's I mean, I always check every like suggestion on Discord, and if they send me links, I always like follow them, try to see what other people are doing with other projects, to get some inspiration, because I think there's still a lot of space for innovation here.
Yeah, well, I will humbly send you the link to my musings. It's really back of the envelope, but I think it's cute, and I was very happy to, again, like as we started with the podcast with the notion of industrial validation. I was very happy to come up with something, and then people say, "Oh, it's like Orleans, basically," and I was like,
Mhm.
"Oh, that I feel." I
That's nice.
feel less ashamed to post it online now. um, cool. Well, yeah, and about the framework that does everything, and then when you have to sidestep something, it kind of collapses. We should have like in our podcast like episodes since we last dunked on Elm, like zero. Yeah, yeah, I absolutely know what you're saying. Um, well, that actually brings us to the question, and I think we should wrap it up and get maybe questions from YouTube chat and or from Siracle chat. Um, so yeah, that brings me to the question of like building on top of Lunatic. This is one thing, right? Like, if I let's say if I want to write my like implement some Rust macros that would do some code generation, and that from that code generation I would like to spawn Wasm instances, for example, using Lunatic. How easy it is to do today, and do you have like plans for that?
I think like it's pretty easy to do nowadays. We also use some like macros for some common functionality. For example, what's like not possible in Lunatic, we cannot really capture the environment of like a closure, right? Because all processes live in different linear memories heaps. So if you're spawning a process, what you kind of can easily do in Rust is just capture the environment inside of the closure. But Rust does not have the possibility to serialize a closure, and it's like an anonymous type. We cannot look inside. So like we have like a bit kind of a macro helper, like so you kind of just forward some information to the process, like you can capture like variables or a tuple of things, and you forward it. So we have a kind of helper macros that allow you to do it, and I think it's like pretty straightforward. Like, it fits well into if you want to build a library. I mean, it's obviously hard to build complex macros and a whole language compiler inside of Rust, but some people have done it. So I can definitely see you building a nice descriptive language that generates all this stuff and does the process spawning in the background and communication. So I definitely think this is possible and doable.
Yeah, we should tip them. We should tip Microsoft Research that Lunatic is the next big thing, and they should already start building it. Um, and what about other languages? Like, for example, I wouldn't say. I mean, people. Some people like Golang,
Mhm.
and I understand them now that it has generics. But one of the things they sometimes mention when they explain why they like Golang is the fact that it interacts with Wasm. So, for example, how hard would it be for me as a Golang user to to make use of Lunatic's capabilities and host functions and etc.
Right. So the Go compiler, I don't think it compiles like to WebAssembly, but there is a project. It's called TinyGo. It's basically Go that was meant for embedded devices, and it has great support for WebAssembly. So you can take I never like tried it in practice, so like the example, but I know like the simple examples at least work. So it's like I take a Hello World application, compile it like to WebAssembly, and because it also uses WASI, the WebAssembly system interfaces, so Lunatic understands those. So you kind of can open files, write to files. You can I think write to system out, like read something from the standard input, and but we don't have a library that takes capability like the specific Lunatic capability, spawning new processes, for example, sending messages to them. So this does not exist. So this like somebody would need to contribute this. We are mostly focused on Rust at the moment and want first to nail this story before we like expand from that point on. But I think it's completely feasible like to do this. And what's also interesting, I think, with as I mentioned, because WebAssembly does not assume anything, and it's such a simple bytecode. Once you compile like tiny Go code to WebAssembly, you cannot really do stack switching and inside of the WebAssembly. So Go routines don't really work when you compile them. In the browser, they make it work because they have this part written in JavaScript, so they kind of turn like when you call something that's supposed to await, they kind of reschedule it and then jump between JavaScript back and the WebAssembly module, and it feels like it's running. Go routines are running concurrently, but this obviously doesn't work in Lunatic because we don't have a JavaScript runtime, and this would we don't have these host functions that would take care of this. So you kind of could just use our concurrency model with Go. So you would not have Go routines, but you could use processes and mailbox, and it really depends on the language. I think the type system and the possibilities, but maybe it could feel like also nice in Go. So you kind of would have like Go the Erlang way that you would write. And I can I think like the simple examples like reading from files like works out of the box right now. You can just compile it, it runs no problem. But like this parts still would need somebody would need to contribute them, so you kind of take care of opening networking connections, for example. I don't think this is not yet part of WASD, so this would yeah, this would need to be worked on.
So for me, like if I want to, let's say, interact with Go programs, I would need to write like a Rust wrapper essentially, and then proxy messages into stdin.
Yeah, I mean, yes. I mean, it would maybe be not be that hard just to write like the Lunatic functions for sending messages are pretty simple. I just like write into this buffer, like this slice of memory, and then like just like send it to this process ID. So can I, if you created a few of those wrappers, you kind of already can take of capabilities of message sending. So you don't actually need like to proxy the standard input. I think it would not be too much work, even if you just like hand coded the small parts that you need to do. But yeah, at the moment, it's I feel like there is this opportunity also because people discuss a lot nowadays how to you should structure your applications, like should you do microservices, should you do monoliths, like small teams, like monoliths, like running, like keep it simple, like big teams, like everybody wants to write. I feel like this kind of architecture comes natural to Erlang because you're already building your application out of small components, processes. And if you just like take them and put them in on different computers, now they don't talk through memory, but they talk through messages to each other. So it's kind of naturally scales, and you don't need to change your programming model. So with Lunatic, like you kind of also get the possibility to write different languages. Right now you're not in Erlang, but you have a WebAssembly module written in Rust and another in Go, and they also talk not now like microservices usually do over HTTP, but like they use the native message sending that it's more performant because it kind of jumps through less text. So, but at the moment, as I mentioned, we were mostly focused on Rust, so we did not explore much of this like whole world of interacting of different languages and how it should work. I know with C and Rust it's easy because you can always like link the C code inside of Rust. So it's like you can take care of some libraries if you need a C library. It in some cases it works, but it's also important to I think, mentioned that you are sometimes limited what you can compile to WebAssembly, because some C code just has some like assembly embedded in it. So you cannot really take any x86 assembly and compile it to WebAssembly. Would not make sense. So like some applications don't even compile, like the compiler would not work. So there are always like limitations there, but I think it could create some interesting architectures.
Well, gladly, I assume that the amount of this applications in C will or libraries will decrease now that we again have a semblance of pluralism in CPU architectures. But yeah, that's a very good point. To wrap it up, I guess I would ask you this: would you recommend Lunatic as a way to get familiar with the world of Wasm for like beginners like me who maybe know Rust, know Erlang, but don't know anything about Wasm? And if so, could you maybe highlight some repositories where us Wasm beginners can draw inspiration from?
Sure. Like there are, I think, two roads you can take with WebAssembly. First, and the most would say common one that people do is like, I want to run some Rust code, some C code in the browser, right? So Lunatic cannot help you much with this part because we are mostly focused on the backend at the moment. So there are many great libraries you can use, like for Rust, BindGen. It helps you basically map Rust types to JavaScript types and make the communication between seamless. So if you're doing some, if you're focused on the browser and you want to run some Rust in the browser, that's a great like decision. But if you would like to run some WebAssembly on the backend, I think like obviously Lunatic is like a great choice. Like we are fairly stable. I mean, it's like now 2 years almost in development. We went to a few rewrites and iterations on it, but at the moment it works. It works good. And I think I wrote a telnet chat application. I think it's like a good starting point because it shows all the, it's not that trivial. First of all, it uses also some Rust dependencies that compile also to WebAssembly, and everything works. So basically how it works, it's telnet is a really simple protocol, and you kind of connect to this server, and every keystroke you type is sent to the server. Like the UI is rendered on the server, and then just a diff of escape sequences is sent back to your terminal, and it's a bit like a Phoenix live view but for the terminal, if you're familiar with it. So it's like a simple TCP protocol. All like the keystrokes are sent to the server, the UI is re-rendered and always sent like back to the client. And it's like multiple people can interact because it's a chat application. So I think it displays all the major parts of Lunatic, and it's like actually not a big application. I wrote it like over a weekend, so it's like you could comprehend it like pretty fast. So I think this is like a good starting point if you just want to get a feel how writing Lunatic like Rust code feels like. I think it's like a good starting point for WebAssembly on the backend.
Awesome. We will link this in the I wanted to say lecture notes in the in the podcast notes. Uh, yeah. Well. Uh, yeah. I guess. Please, Bernard, tell us anything you want our viewers to know about your project, about how to contribute, about what's the most important uh, thing you may want to ask the community.
Yeah, I mean, we are completely open source, so all the repositories are available, and we provide also binaries like and easy way to install the runtime. So we want to make it really easy for people to try it out. So like if you can do it, like, and if you're interested in Erlang, Rust, and especially if you have some Rust experience, like I would love for the viewers to try it out and give us some feedback. Join on our Discord channel. And at this like early stage, I feel like there is like people have a lot of power to shape it, like to push it in a direction, because we are also open for suggestions. And I mean, I have a lot of experience with Rust and with Erlang and the world, but like there are some other really cool projects that I'm not familiar with, like, that people point me to, and I'm like, wow, like look, we could have done it that way. So like I'm really open to suggestions, and at this like stage, I would just encourage everybody to try it out. And if you know some Rust, like you could also help contributing. Obviously, to the project, we are always looking for contributors. Yeah, I would say like those are the two main points. Try out some, give us some feedback, and yeah, hopefully people like it.
Yeah, and I think that's the story of Lunatic is very inspirational because it's a full time job for you now,
Mm.
which is a dream I think of any person who has like a who's serious about their pet project to make it a full time job. So very good job on that, Bernard, and Puno hvala for sitting down with us
Mm.
today. Um, yeah, thank you. I don't know if we have any questions. Um, Let me just triple check that we don't have any questions, so people
Okay.
understood everything. I think
Wow.
that everyone now knows how to use what is Wasm and how to use it. So amazing job.
Thank you
um,
very much. It was great, like talking to you.
all right, thank you, bye.
Bye.